Hello friends, this is Gohil and welcome to our channel GPSC Network. Now in this video we're gonna talk about the two things which is most important for the next upcoming competitive exam like GPSC, UPSC and SSC. Now in this video we lot to know, a lot to discuss, but before we begin, please like, share and subscribe our channel, and thank you very much for this. Now without wasting of time, let's get started. Now in the fluid mechanics, which is the branch of the engineering of science, deals with a study of the particles, fluid particles at the rest situation as well as in motion situation. Now the branch of the engineering of science deals with the statics, kinematics and dynamic aspect of the fluid, so that the application of fluid engineering is very wide. We can say that a water of the flow of river, flood flow, breathing, pumps, fans, turbines, airplanes, engines, ships, etc. Now just assume that the fluid mechanics, which is defined in based on the fluid which is a rest situation as well as in motion situation. So now just assume that the fluid which is passed over the solid surface, if the flow which is in a rest situation, there is no relative motion between a two layers, so that the velocity of the fluid particle is zero and the shear stress of the fluid particles which is also been zero. Now when the fluid which is passed over the solid surface, that time velocity and the shear stress are there, and so that the continuously action of that shear stress, fluid particles continuously deform under the action of the shear forces. Now the fluid mechanics we can define as a substance which is deformed continuously under the action of the shearing force, however the small they may be, right? Now just look at this figure number 1 and figure number 1.1. Now just assume that the fluid particles move parallel to each other in the figure number 1, and the figure number 2 we can see that the fluid particle which is move parallel to each other, but the velocity at the surface of solid, that time velocity is zero and the shear stress which is maximum. Now with increase the distance from the solid surface, the velocity gradually increases and the shear stress gradually decreases. So we can conclude that the shear stress which is inversely proportional to the velocity of the fluid from the solid surface, right? That this is the fundamentals of the fluid mechanics. Now move on to second things, which is the Newton's law of viscosity. Now look at this figure number 1.2. Now fluid element, we can say that the A, B and C placed between the two plates distance dy apart. When the force F which is applied to the upper plate, it causes it to move at the small speed du relative to the bottom plate. The force per unit area, we can also say that the shear stress of force per unit area, and the d theta which is the, we can say that the small angular displacement, right? So so that so first of all we need to find out a distance bb dash or cc dash. We can calculate by using and speed and time. The bb dash which is equal to a speed into time. Now what is the speed which is equal to a du, and time which is equal to dt, right? So now again bb dash we can also calculate with the help of the angular displacement. Now just assume that the angular displacement which is the very small, that so that we can directly use that a tan theta which is equal to bb dash divided by dv. Now this d theta which is very small there. Now so that calculate the bb dash which is equal to d theta into dy. The equation number 1 which is equal to du into dt, and equation number 2 which is equal to dy into d theta. Now compare these two equation 1 and 2. Du into dt is equal to dy into d theta. Now the expression of this du by dy which is equal to d theta by dt. Now du by dy, which is also called as the rate of shear strain, or we can also say that the strain, right? Now assuming a experimental result of that, a shear stress which is the directly proportional to the shear strain. Now what is the shear stress? The shear stress, we can say that a tau which is directly proportional to du by dy. So now the proportional, to remove a proportional sign, we can add a constant. We can here the constant which is added here, the dynamic viscosity. And so now the tau, which is means a shear stress which is equal to mu du by dy, where the mu, which is the dynamic viscosity, and the full equation tau, which is equal to mu du by dy, which is called as the Newton's law of viscosity. So now the conclude that a shear stress of the fluid which is directly proportional to the rate of change of shear strain. Thank you very much.